Welcome back to STEM Online Academy. My name is Jason Master Ackles, if you don't know, and we are a advanced online mathematics and physics tutoring uh, company. All right, so we're going to be looking at something very interesting today. We're going to be looking at this particular integral right here that I'm pointing to. Okay, so if we can look in the second screen, all right. So we're going to be looking at this guy here. We want to evaluate this very interesting integral, right? And we're going to use the right method for it. So we want to integrate 0 to 1 of x times ln of 1 plus x squared with respect to x. Okay. Now, most of you guys, most students will get this question. Um, they ask the wrong question when it comes to solving this integral. Okay. And they ask the question that they're asking, sorry, is what formula should I use or do I use or whatever. Okay, but strong calculus students know better. But strong calculus students know to ask a really important question, right? What structure is hidden in the problem, right? And what I mean by that is, you know, geometrically and so forth. And today we are going to evaluate this integral, right? We're going to evaluate it. We're going to break it into parts using my systems-based technique. For those of you who don't know, for the first time, it's a very strong technique that helps. Uh, that's helped a lot of people solve hard math problems. Okay, and more importantly, I'll show you how to use the correct method. This correct method before solving. Okay, my visualize, model, uh, visualize, model, verify, and execute method. Okay, so let's get into that. Okay, let's get into what I mean. Okay, and where this method came from. Okay, so at one point in my life, I was not good at mathematics. Right, when I was in grade 7 to 9, I was struggling like hell when it came to mathematics. Okay, like I knew like the procedures, but I didn't know the problem solving, like the problem solving and the discernment that you need behind the doing actual mathematics, if that makes sense. I'm sure a lot of you can relate to that. Like you think you know math, but you actually don't. Okay? And as I said, it's not because I couldn't learn, it's because I just didn't know how to break hard problems into a system. Okay. And then two teachers actually changed my life. All right. Um, they didn't give me this system per se, but they told me that you need to develop your own system, your own problem solving system. All right. Uh, and they taught me not to panic. And quite often, when it comes to the most important thing, more than solving, like trying to solve algebraically the problem, is if you don't have the method, if you don't have a problem solving method, you don't have a calm way of thinking, you get nervous in terms of problems, you're going to end up messing up. Okay, so don't do that. Right? We're going to think clearly. I'm going to show you the method. All right. They're not solved through panic or emotions. They're solved through structure. All right. So when it comes to that structure, this method helped me tremendously. And actually, not only did I do very well in high school, in my later years, I went on to a university for a double major in mathematics and physics, graduated with a 3.85 GPA. That's a very good GPA for those of you who don't know. Yeah. A Bachelor of Science, double honors. All right. And from there, I said to myself, do I want to continue to grad school or do I want to? It was more important for me to change people's lives and students' lives and whoever else who wanted to learn mathematics to make the hardest problems easier. Okay. All right. That was my goal. So if you understand calculus in class, but you're freezing, with exam type problems, well, as I said, STEM Online is the place to be. All right. STEM Online is the place to be, especially when the unfamiliar problems arise. Then this video is for you, and all my videos are. All right. So let's look at stating the problem. Right. So we have this integral, right? The integral from 0 to 1 of x ln of 1 plus x squared with respect to x. Okay. That's what we're dealing with. Now, I want to be able to break this apart. So we want to use that. We want to be able to use my method. Okay. Step one of my method is you want to visualize. Okay. So when I mean visualize, it doesn't always mean like with a graph or a simulation or some sort of geometry. That being said, it helps to draw it, right? So it really helps to draw it, actually, a lot of times. Today I'm not, but anyways, we're going to approach it this way, right? So we're going, what I mean visualize this here. Just give me a sec. Okay, so I want you to visualize this. What I've underlined, our function, our integrand function, x times ln of 1 plus x squared. Okay? And I want you to visualize that because of the fact that it's going to lead us to step 2, which is to model. Okay? I'm going to break this function apart, f of x, right? We'll call the inside function, or the function to the right to be more accurate. I should have said that function to the right, which is the ln of 1 plus x squared. We're going to define it as something. Okay? The inside function g of x equals ln of 1 plus x squared. All right, that's to the right. And to the left, the left function, or the outside function, is going to be h of x. Second, both these guys make up our function x ln 1 plus x squared. Okay, now we've got that. So that was our model. So the model portion is just telling us, is giving us a framework or some sort of schematic, language schematic of what we have and don't have and what we need to define and stuff like that. Once we have our, once we visualized in step step 2, once we've modeled, and then step 3, we want to execute. So how would we go about integrating this bugger up here? Okay. For those of you who know, you should know. Otherwise, I'm a bit concerned about you and your calculus 1 or calculus 2 courses, right? Is you need to use a type of substitution, and that substitution is called U substitution. Okay. You want to depict your U, right? You're going to depict your U right here. Let me just highlight. Here's your U. Your U is 1 plus x squared. Now, why did I say that? Why did I choose U to be 1 plus x squared? Take a moment to think about that. Why did I make U equal to 1 plus x squared? This is in our execution phase. Very simple. Because if I let U equal 1 plus x squared for U substitution, I know I need a differential of U. And if I get my differential of U, that will be with respect to x. That'll give me a 2x dx on math. Okay? And you'll notice that we have an x dx factor outside. See that x, the x and the dx, right? That will be for our differential. That's why I chose the U, 1 plus x squared. And then we can integrate. We know how to integrate ln of U. I'm not going to go through all the algebra, right? I'm just going to give you the most important things, right? That is going to give you, that insight. You know what I mean? Sometimes, quite often, we don't need to do all the algebra to explain it to somebody. Because most of the times, I expect by now you guys understand the algebraic mechanics of how to solve an equation. If you don't, then if you're in grade 12 or first year university, you may have a problem. But what my job is to make sure you understand the reasoning behind the problem. Okay? So that's what I'm trying to do here, right? So letting U equal 1 plus x squared, du will be 2x dx. Then you know that we have a formal integral for ln of U. U substitute, not U substitution, integration by parts to do it. But when we do that, remember, we're still in terms of some U or V. as you can see here. Okay. We want to get back in terms of x because we're integrating with respect to x. So we also want to make sure, sorry, my mistake. So we know how to do this, right? We know how to go from x in terms of u from the u substitution. All right. Now, when we do that, we need the limits of integration for u. Okay, we want the limits of integration for u because we're in terms of u now. So we have to get rid of the x. So the lower limit of integration we said was x equals 0 in our integral. Okay, upper limit of integration was x equals 1. Since we know u is a function of x, our integrand function, not integrand function, sorry, our our u substitution, right? Our u substitution was 1 plus x squared. Okay, substitute x equals 0 for the lower limit, and then we get an output for u at the lower limit in terms of u. So u is 1. Okay, very straightforward. Upper limit at x equals 1. U equals 1 plus x squared, plugging in x equals 1, we get u equals 2. Upper limit of integration is u equals 2. All right, so that shouldn't be hard to deal with, if you know what I mean. Okay, it's not some really brilliant stuff. It's straightforward, right? Okay, so now that I've got that, okay, we should end up with this. This is what I've calculated. You can verify this, okay? And if you have any questions, you can leave something in the chat below, or if you want to dispute my results, you can say something in the chat when the time comes, once this video is uploaded. So yeah, so this is the integral. After integration, we get ln of 2 minus 1 half. Okay, so that's what we end up with. All right. Now we executed, we got a result. Let's not rush to conclusions. We need to verify this result. So I want you to notice that this integral, above, ln of 2 minus 1 half is a positive answer. If you do ln of 2 minus a half, you get a positive result. So step 4, notice that our integrand, remember our integrand function was f of x equals x ln of 1 plus x squared, right? On the interval 0 to 1, because we're integrating from 0 to 1, limits of integration. However, if we're doing that, if we're going from 0 to 1, that means we should be putting any x value included between 0 and 1 here. You understand what I mean? Any x value between 0 and 1, you can test those values in here, right? For instance, if we put x as 0, we're going to get this whole thing to be 0 f of x, right? And if we put in x as 1, right, we're still going to get a positive value, ln of 2. I know ln of 2 is going to be positive because of this, right? Watch carefully. ln of 2 would be something like this, right? So for log functions like that, sorry about that, try to make it more accurate. ln x is like this. Okay, ln x is like this. And ln of 2 is obviously, ln of 2 is obviously greater than ln of 1. And we know ln of 1 is 0, right? So that would have been right on this asymptote here in the axis. So we know it's to the right. It's a positive value. So that means that any x value between 0 and 1 means that f of x is greater or equal to 0. Okay? And since that's the case, and our answer ln of 2 minus 1 half is positive, then our answer makes sense. Okay? So I brilliantly used my system, condensed the problem, only did explain the most important points that majority of students would miss. Okay? And I went right to the point. Okay? That's what real math teaching is. Real problem-solving math teaching, because nowadays I don't even know if teaching math in school anymore is problem-solving. Yeah, I'm going to talk about that in a second. Um, so yeah, that is it, right? So we verified it. Okay, we verified, and we've now entered the realm that I want to talk about next is when it comes to exams. Okay, all right. So the important lesson is not just to get a final answer to your question, right? As I said, it's about the problem solving. You want you want to be able to know how to think, not to get the answer, because maybe you got the answer by just coincidentally memorizing a formula or a trick from a very similar question. That doesn't count. You want to know how to think. You want to know how to use methods. Right? We didn't guess. We just asked a very simple thing. The inside function, the outside function, is a part of some derivative present? Can substitution help? Um, all these things, right? This is what real calculus is analyzing the behavior. Okay, and her exams don't only just test whether you know the techniques; they test whether you choose the correct, the right technique when the problem is very unfamiliar, right? When it's non-algorithmic, when you can't, immediately use this specific formula for this specific problem for no. Quite often on a real hard exam, you have to be able to use discernment slash judgment and be able to make differentiations of what I can use, what definition or theorem can be used, what's the difference between the definition or theorem or formula, doesn't matter, um, for what cases, and then be able to deduce what to use. Okay, so the system was, as I said, visualize, and then you want to be able to model, you want to be able to verify, you want to be able to execute, right? And that's exactly what we did. Okay, so if you're understanding calculus in class but still are having, a freeze up on difficult midterm and final exam questions, this channel's for you. You've come to the right place. Okay, I'm Jason Masterakos from STEM Online Academy. Again, uh, well, before I get into that, I do want to mention one thing before I close with closing arguments. Uh, as I say, if you understand calculus in class, but you're freezing on difficult exams or final exam questions, not only is this channel for you, you may want to pick up my free PDF, and that's on my systems technique. So I use 7 different examples, rigorous examples of where this technique can be handy. It's completely free. Please download it. You have any questions, please put something in the chat and I'll fix anything you want. So the systems technique is free. Now, if you don't understand the systems technique and or you're not understanding the math that I'm putting up, it may be because you have a prerequisite problem or logically you're not able to put things together. I have a book, my new book. It's very rigorous. Introduction to logic, used for all math courses. Without logic, you can't do math. Okay, and it teaches you how to think logically and different methods of logic. Okay, and not just that, even if you don't foresee those logical techniques, it talks about in this book the properties of functions, which is what this problem was referring to quite a bit. Integrands, how the function is, how I knew to graph this function, how certain things on intervals and stuff like that, real numbers. My book discusses part of that. So Axioms is available. Um, you can ask me about it. Be in the link below this YouTube video. So please check that out. And let's see what else. Yeah, if you're struggling, if you're really having an issue with anything, when it comes to calculus, right? Uh, it may be good because especially I'm taking up mainly more complicated rigor-based calculus, so it may be good to also look at my book, Axioms. Okay, all right. So if you understand calculus in class, but you're freezing on those difficult midterm and final exam questions, this channel is for you, my friends. It's absolutely for you, right? I'm Jason Masterakos again from STEM Online, and I help serious students tackle hard calculus and physics as well, physics problem solving questions using verify, then model, then execute, then verify. The goal is just not to get the answer, right? That's not the goal. The goal is to know what to do when the methods and systems isn't obvious. Okay. Thanks again for watching. I want to thank my subscribers, new subscribers. Please subscribe, like, and subscribe. And I promised you guys, if you, for those of you who were saw my last videos, that I would do 2 to 3 times a week. I'm going to push to 2 times. So I'm very busy. 2 times is perfect. Okay. So like and subscribe. Things are going to get more interesting than this. If you like a challenge, you're also in the right place. Thanks again. Like and subscribe. And I want to thank you to my subscribers. Have a good week.